Hello everyone, welcome to my channel. Today we will discuss Leetcode question number 84, which is largest rectangle in histogram. So let's read the question. Given an array of integers heights representing the histogram bar height where the width of each bar is 1, return the area of the largest rectangle in the histogram. So you will be given array of integers which is height representing the histogram bar height. So each of the index value will representing the height of the bar, and width of each bar will be considered as 1, and you have to return the largest rectangle in the histogram. So let's see the example discusses. Okay, so first example is 215623. So 215623. So in this largest rectangle that can be formed is this one, which is of area 10. So how it is done? The width is considered as 1 and 2 bars are there. So width is 2 and height is 5, which is the height of this bar. So 5 into 2, which is 10. So area is 10. So other rectangles are also there, which is this one, but area of this will be height is 2 and width is 1, 2, 3, 4. 4 to the 8. So this area is 8 only. Another also could be like this. Okay, so width is 1, 1, 2, 3, 4, 5, 6, and height is 1. So it will be 6 only. So among all this, this is the maximum, which is this one. Okay, so let's discuss the approach. So one of the brute force approach that we can do is a standing at an index. We can we can see what is the next minimum. Okay, till there only we will go. So if I'm standing at this index, and if we look at left, so minimum is this one. So what we will do, we will take one index beyond that, which is this one. So we will consider this only. So this we will consider our left minimum. And looking on the right, the minimum is 2. So we will take this one. Okay. So yeah. So for this index, we found that we can go here only. We can't go beyond this, because if we go beyond this, we are getting 1, which is smaller. So our area will reduce. And on the right side, we can go till here, because after this, we are having 2, which is less. So for this index, we will calculate the difference between these two index. It means that the length of this two index. So it is 0, 1, 2, it is 3, it is 4, and it is 5. So the indexes are 2 and 3. So what we will do, we will take 3 minus 2 plus 1. So 3 minus 2, 1 plus 1. So we will get the width as 2. And height we will take, minimum. Height we will take minimum of both left and right. So from left, we get this 5 only. And on the right, we get this 6. So minimum of both is 5. So our height will be 5. And we will calculate the area 5 into 2, which is 10. Let's take some other index. So if we take this index, okay, 2. So we will see how far we can go on the left. Means we will search for the minimum height bar lesser than 2. Means we will search for bar of the height which is lesser than 2. So we can see that 2 is minimum, sorry, 1 is minimum than 2. So we will take one index beyond that, which is 5. Means till here we are getting bar which is greater than or equal to this 2. So we can take that only. The graph, the bar which are greater than this, greater than the current index bar height, we can take those only. So that's why we are searching for the minimum. Okay, where I'm getting the minimum. So I'm getting minimum at this index. So if I'm getting minimum at this index, then our means the bars of the greater height lie on one index before that, which is 5. Okay, so we got that index. Let me mark the index again. 1, 2, 3, 4, and 5. So on left we got index 2, and we will search for a minimum on the right. So on the right we got this. There is no minimum. So this index will be our right index, because there is no minimum. Minimum means lesser than 2 on the right side. So that's why the last index will be the index that I'm looking for. As we can see that 3 is larger than 2, so we can take that. So our right index will be 5. Now we will calculate the width. We will calculate the width by 5 minus 2 plus 1. So it will be 3 plus 1, 4. And height, we will take the current index height only, because that only I know the height, because whatever height lies on the right or left is sure that it is greater than 2 or equal to 2. So that's why we'll take the height 2. So we will multiply it with 2. So it will be 4 into 2, which is 8. So 8 is lesser than this, the previous that we calculated. Okay, so this is the brute force approach. So time complexity for this will be n square, because we will be running one for loop for iterating this array, and inside that another for loop we will running to find the left minimum and find the right minimum. Find the left minimum and find the right minimum. So it will also take O of n times. So time complexity will be O of n square. So it is obvious that interviewer won't be happy. So we need to optimize this. So to optimize this, what we will do, we will pre-calculate the right minimum and the left minimum for each index, and we'll store them in an array. Okay, we will create two arrays. So it is of the same length. So we will create two arrays of length 6. So this array will tell if I'm at this index, so this index will contain the value, or it will contain the index of that bar graph which is smaller, which is next smaller than the current index. So let me fill this array. Okay. So starting with 2. So 2 is having no one on the right, sorry, on the left. So for 2, we will keep it -1. Okay. Now coming to 1. 1. So we can see on minimum means next minimum of 1, no one is there. So for 1 also we will keep -1. Now coming to this 5. For 5 we can see that 1 is the minimum. So we will add this index to this to our array, which is 0, 1, 0, 1, 2, 3, 4, 5. So here it will contain 1. And for 6, we can say the minimum is 1. So for 6 also it will be 1. And for 2, the minimum is 1. So index will be 1. And for 3, minimum is 2, which is index 4. Okay. So this array, what this array is telling? This array is telling if I'm standing at an index and I want what is the minimum on my left, so I can get this from array. If I am standing at 2, which is here, this one, and I want what is the minimum on my left, so I can directly check that index 1 is the minimum, which is this one. Okay. In the same way, we will create another array for the right minimum. Okay, that's 6, yeah. Same for 3, nothing on the right, there is no minimum. So for that, we will not add -1 in this case. We will add the size of this array. Why I'm adding size of this array? Because what we are doing, if we are standing at an index and if we found that minimum, suppose we are standing at the 6, okay, and we found that minimum is this index, but we don't need this. We need index prior to that. So we are doing a -1. And if we are checking for the left, we are doing a +1. So suppose if we are looking for 5 and we found that 1 is the minimum. So we don't need this. We are looking for this index. So we are doing a +1. That's why for left, I have added -1 for the starting index. So in the same way, for the right, I will use the size of this array, which is 336. So it will be 6. And for 2, also there is no minimum. Again, it will be also have 6. And for 6, 2 is minimum. So which is index 4. And for 5, again 2 is minimum. So index 4. And for 1, no one is minimum. Again index 6. And for 2, 1 is minimum. So index 1. Okay. Now we are ready with this arrays. So this array is telling which is minimum on the left, and this array is telling which is minimum on the right. Now let me show you how we will get result using this. Okay. So if I am standing this index, which is 2. Okay. So now I don't need to check on the iterate on the left and on the right. I will simply go to this array. Let's say it. Okay. So this we will simply check in this array on this index. We got that key one index is the next minimum from this. So we will use this index and we'll do a +1. So we got 2. Means 2 is the index that we are looking for. And for the right minimum, we will check this, which is 4. So we will do a -1 there, which is 4 minus 1, 3. Okay. So we got this 2 index. Now we will calculate the result. 3 minus 2 plus 1. So we got the width 2 and we know the height, which is 5. So 2 into 5, 10. So we are getting the result. Okay, so till here, everything is clear, right? Now we will see how we will create this, array. Because if I will create this array, so for creating this, I will require a time complexity of n square, but it will be same as the before. So we need to do this in O of n. So how we will do this in O of n? We can do this in O of n using a stack. Okay, so let me show you how we can do this using stack. Let me mark the index again: 0, 1, 2, 3, 4, 5. Now we will take a stack. Okay, and in the beginning, I will I will push -1 into the stack here, and we will create the array. Hmm. Now I will check कि, uh, now I will start with the 0th index. Now I will check if stack top element is greater or smaller. If the stack top element will be greater, then we will keep popping it till we get the smaller one. Okay, so we are starting with the 0 index, which is having 2. So we can see that 2 is greater than -1. So we will place this value -1 here, and we will push this 2 in my stack. Okay, now coming to next index, which is 1. Now we will check whether the top element is lesser than 1. No, it is greater than 1. So we will pop it. Now we will see top is greater than 1. No, it is -1. So we will add -1 to this index and will push 1 to my stack. Now coming to this 5. Again, we will check whether the top element is greater. No, it is not greater. So we will we will take this top element and keep it in our array and push that. Sorry. We will be pushing the index, right? Sorry for this. So 1 is having one index. Till now it is correct. So for 5, we will be pushing index 2. Okay. Now coming to 6, we will check whether the top element is greater. So it is index 2. So index 2 is 5. So 5 is lesser. So we will simply uh, yeah. So we will place the index 2 here, and we'll push the index 3 to my stack. Now coming to 2. Now we will check whether the top element is greater than 2 or not. So index 3 is 6. It is greater. Then we will pop it. Now coming to next. Next is index 2. Index 2 is 5. So 5 is greater than 2. Then we will pop it up. Now next is 1. So next is 1 index and the value is 1. So it is smaller. So we will use its index and place it here and push the index 4 into the stack. Now coming to next index, which is 3. Now we will check whether the top element is greater. So it is index 4. 4 index is 2. So it is lesser. So we will simply place the top index, which is 4, and we will push this 5 to our stack. Okay, so we are done and our array is ready. So let's check it. If I am at 5, okay, which is index 2, which is 1. So 1 index is the minimum, next minimum, then 5. Now, if I am at 2, which is index 4, so 0, 1, 2, 3, 4, this one. So it is telling that 1 index is the minimum. So yeah, 1 index is the minimum. 1 is 1. So this is the next minimum for this. Okay, so in the same way, we can create the right minimum array. Okay, and after calculating both these two, we can get our result. So let's see the code. Yeah. So I have created one function that will be creating the left minimum array and another function that will be creating the right minimum array. So for this, I have taken a stack and created a vector of of size 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 of the given array, and I'm running the loop, and inside that I'm running a while loop and checking whether the stack is not empty and the the top index that a stack is having is greater or equal to the height that currently I am. If it is, then we are popping it up as we discussed. Okay. And after that, after this process, the stack will have minimum at its top. So we are checking if stack is empty. If it is empty, then we will, if it is not empty, then we will push the top, we will assign our resultant vector with the top element. If not, we will assign it with the -1. Okay, so while discussion, I have pushed -1 in the beginning of the stack. So that will also work. I haven't used that logic here. So that will also work. You can try that. And this will also work. So if a stack is empty, I'm assigning it with -1. And after that, I'm pushing I to the stack. And in this way, we are getting our left minimum array that will be containing the what element will be on the left for a particular index. So let's move ahead. Now, in the same way, this get right minimum is implemented. We are having a stack and a vector and running a loop. The same process there, same process this. Now let's move to the main code. So here what I have done, I have taken two vectors, left and right, and call that function get left minimum and get right minimum. This will be returning as the vector containing the left minimum and the right minimum. After that, I've taken a resultant variable and I'm running the loops, running a loop over this height array, and I am calculating the left minimum. I have taken the left minimum plus one element, means element next to that, and for right I have taken right of that index -1. Okay, and we got our left and right, means till where I can go on the left and till where I can go on the right. So this left and right are containing the minimum as for a particular index where I can get the minimum on the left, but I don't need that minimum. I need element next to that if I'm looking on the left, because on the left uh, element next to that will be greater than and equal to my current index that I'm processing. Okay, so we got our x and y, and we are calculating the width, which is length, and distance means width of the rectangle. So it is y minus x plus 1, and I'm maximizing my result, which is max of length into this length and this height I current element, and the height I and the result. Okay, so yeah, so after that I'm returning the result. So let's run this code. Yeah, it's passing all the given test cases. Let's submit it. Yeah, it passed all the given test cases. So time complexity for this will be O of n, as we are running a single loop and iterating over the height array only. And for calculating this left minimum and right minimum, we are using only O of n times. So it is total of, it will be O of 3n, which is equivalent to O of n. And the space complexity we are using is O of 2n, which is equivalent to O of n only. So time and space complexity for this is O of n. So thank you for watching. Do like, share, and subscribe.